Okay, we are going to investigate now the extrema of the graph. Of the functions. Now we're going to read a graph like you read a book, from left to right. So if I'm going from left to right, what do we notice? From left to right, what's it doing right here? It's going down. It is decreasing. And then right here, do you notice how it's decreasing, decreasing, decreasing until it hits that point? And then it starts increasing again? That point is called a local minimum because it's kind of a low point. It's a valley. I like to call it a valley. It's a local minimum, which again, I call a valley. We live in the Willamette Valley. Now, it's going up. Once it starts going up again, it is, again, going from left to right, it starts to increase. So now we are increasing. Okay? It's going to keep increasing until it hits this point where it starts to decrease again. Notice this looks like a mountaintop. We call that a local max. So this right here is a local max or local maximum, and I call that a mountaintop. Okay? And then what happens after the mountaintop? It immediately starts decreasing again. The important thing to notice is every valley comes because we're decreasing and we get to our low point and then we start going up again, so that creates a valley. But when we're going up to a high point and then back down again, that creates a mountaintop. Okay? So let's look right here and determine some boundaries. What do we see? We see that it is increasing. So going from left to right. We see from left to right, this is going up when x is less than 0. So when is it increasing? For x is less than 0 right here. So when it's less than 0, boom, we see that increase. And we see another increase right here when it starts to go up again when x is greater than 4. And where do we see it decreasing? Well, we see it decreasing in an interval when x is between 0 and 4. So we have 0, 4, when x is between that. What do we see? We see when x is between that, it's decreasing all the way between 0 and 4. Okay? And where's our local maximum? Our mountaintop is right here at the point 0, 0. Where's our local minimum? Our local minimum is right here at the point 2, 4, and then negative 8. So 4, negative 8. Take a minute. I don't need you to identify the increasing and decreasing areas, but identify the local maxes and the local minimums and write down the letters associated with them. Ready, set, go. Okay? Hopefully for local max, all the mountaintops is B, D, and F. And the local minimums is all the valleys, which is A, C, and E. Ace. Okay? Awesome. So notice, this, by the way, is paying attention. If I'm looking at a graph, so let's look in this graph right here. What am I paying attention to? I'm paying attention to that middle area. I want to know where are all the mountains and valleys, the local mins, the local maxes. But now I want to talk about something different. So we've been paying attention to what the graph's doing. The local extrema looks at the middle, where it's increasing and decreasing. Now I want to look at end behavior. The end behavior of a graph is a little different. It's just focused on the ends. So not that middle part, we don't care about it, we just care about the end. And we're going to learn to write something kind of different. So in this end behavior, look at it. Let's talk about as x decreases. So to decrease, so as x decreases. that means it's going left. Notice that as my x decreases and goes left, what do we see the end, just this end doing? We see y is increasing. So y increases. But then, as x increases. So this, by the way, is talking about this end behavior right here. Now, as x increases, so as my x is further going to the right, what do we see that our y value is doing? So again, going to the right, we see that our y decreases. It's going further and further negative. Okay? So we're going to describe the end behavior. And this is said in a different way. So, as x decreases, we would say as x. This means approaches negative infinity. So x is getting infinitely smaller. What do we see happening right here? We see y increases. Y increases would be written as y approaches, it's increasing, positive infinity. Like the infinity gauntlet, infinity stones, yeah, recognize some things? And then when we would say as x increases, similar to the y, when x is increasing, we're talking about x approaching positive infinity, so going on forever to the right, okay, forever to the right. I guess that's left for you, but forever to the right. Then what do we see right here? We see y decreases. Which is y approaches negative infinity. Let's practice more of that. We're learning a language kind of. Pause this as needed. Let's roll. Describe the end behavior. So I'm just looking at the end right here. Let's see. As x approaches positive infinity. So positive infinity is going to the right. Okay, it's right here. As x approaches positive infinity, as x is getting further right, what is my y doing? It's going down. So that's going to negative infinity. Now this one's up here. This says as y decreases. So in other words, as y is going left to negative infinity, what do we see that y is doing? Y is increasing, so y is approaching positive infinity. Now again, this is end behavior. So because it's end behavior, we're just looking at the ends, right? And let's see. As y approaches, or as x approaches positive infinity, which means it's going to the right, and we see it's going up nonstop, so we see y approaching positive infinity. And to the left, as y approaches negative infinity, so it's going further and further left, we see this is going further and further down, so y is approaching negative infinity as well. Awesome. Well, guys, this is a lot, but I think you're going to handle it and crush it. With that said, peace out.